Today, we are focusing on the second half of this stuff that we learned yesterday. Yesterday, we did cardioids and limesons. Today, we're going to do roses and spirals. The graphs themselves today are really easy to graph. So if you struggled yesterday with like limason and loop, these are a lot easier to graph. There's a little bit more reasoning behind why the graph is set up the way it is, but we'll get through that. The graphs themselves are easy. The reasoning behind it is a little bit more complex. Let's see what we can do. We are solving this thing on the interval from 0 to 2 pi. Notice that I'm in radians instead of degrees. It's fine. Don't let that be weird to you. If I were to solve this thing, we spent the month of December doing these problems. Okay, this is what we did in December. We divide both sides by 5. Sine of 2 theta is going to be equal to 1. How? I want to get theta by itself. What do I need to do to get rid of sine? Inverse sine. Earlier, we like to say cosecant. Cosecant is not the inverse. It's the reciprocal. And so instead, I want to do inverse sine on both sides. 2 theta equals everywhere that sine is 1. Where would sine get you 1? 90 degrees. We're in radians, so it'd be pi over 2. Everybody agree with me so far? Then we get this guy right here. We get a 2 out in front. What does it mean if you have a 2 in front of your theta? It means you're going 2 times around, or it's 2 times as fast. That's probably the better description today. It is 2 times as fast. So, pi over 2 is an answer. What else do I need to do? I have another answer. I'm going to have 2 times the amount of answers. What else would I need to do here to solve? Add 2 pi. All right, well, I have a denominator of 4, so it's really like adding 4 pi over 2. So I'm going to take 4 pi over 2 plus that. It is going to get me 5 pi over 2. Is that my answer? What else can I do? Divide by 2. It's like multiplying by a half. Boom. Theta equals pi over 4 and 5 pi over 4. Everybody okay with me to that point? Let's show you what we just did. So we just said R equals. We said R was 5. That's what we did. But we're going to just say R equals 5 sine 2 theta. Is that correct? All right. There's my graph. Know the 2 points we just found. We said pi over 4, so right there, and 5 pi over 4 right there. The R, what it was going to be equal to, was 5. We agree with that. That's what we got. We got 2 of these. But I only got 2 of them. I also have a radius. I'm going to put that in radius of 5 in quotes. And I'll show you why here in a second. Where are these 2 values coming from? We found these 2, but we didn't get the other 2. Anyone have any ideas about where I found those other 2 radiuses of 5? It's strange. Let's look at it. The reason we're not seeing those other ones is because what we really found was a radius not of 5, but a radius of -5. Okay, the other 2 dots are places where the radius is -5. Because if your radius is -5, it's just going to be across the other side. Just watch. You don't have to do it on your paper. I'm going to do it real quick. Sine of 2 theta equals -1. Inverse sine, so 2 theta would be 3 pi over 2. We add 4 pi, so we get 7 pi over 2. I divide by 2, divide by 2, divide by 2. Oh my goodness, that's ugly. But what I end up there is 3 pi over 4 and 7 pi over 4. Yeah, that's what we had, 3 pi over 4. If I started at 3 pi over 4, but I had a radius of -5, I would ride the line across the other side. And if I had 7 pi over 4 at -5, I would ride across the other side. That is why I'm getting 4 different petals on this graph. Because I have a radius of 5 and of -5. And so it shows up twice. Does that make sense on the first one? All right. Keep that same energy. Let's try the second one. 6 sine 3 theta equals 6. 6 sine 3 theta equals 6. If I want to solve that, Kara, what do I need to do first? Yes, ma'am. Divide by 6. Then what you want to do? Inverse sine. We want to get rid of sine, so we're going inverse sine. That's going to cancel. 3 theta equals. When is sine 1? Well, we said that was at pi over 2. Everybody good to that point? We've got a 3 in front of that theta. What does that 3 represent? We're going around the circle. We're going 3 times as fast. Okay? 3 revolutions, whatever you want to say. They all mean the same thing to me, but 3 revolutions. I got pi over 2 as 1 revolution. We want to add 2 pi. But to match my denominators, I'm really going to add 4 pi over 2. That is what I'm going to get the second time around, so I get 5 pi over 2. Am I done? What else do I need to do? Do it again, because that was only the second time around. Now I need to find the third time around. So if I add that again, 4 pi plus 5 pi is going to get me 9 pi over 2. And then to finish, I got to get rid of this 3 in front of the theta. So it's like I'm multiplying everything by 1/3. So if I simplify that down, I get theta equals pi over 6, 5 pi over 6, and 9 pi over 6, which is 3 pi over 2. Everybody understand that part? Let's graph it. So this time we are graphing r equals, is it 6 sine 3 theta, correct? 6 sine, 6 sine 3 theta, go away. There you go. All right. Let's find those values. Well, we said it was at pi over 6, the radius is 6. Yeah. 5 pi over 6, the radius is 6. Yeah, we're good there. And 3 pi over 2. Boom, we got them. Those were the 3 spots we had. Everybody understand what we did? Now, that's different than the last one. The last one, we had these extra ones that we couldn't account for. This time, we don't see any of those extra ones. Let's see why. As I'm passing out notes here, try and solve this question. When is 6 sine 3 theta going to be equal to -6? So when are we going to get that radius of -6? Try and solve that real quick with your neighbor. See what you get. Let's solve this. I'm going to go pretty quick here. Divide by 6, divide by 6. Sine 3 theta equals -1. We do inverse sine, so 3 theta is going to be 3 pi over 2. I've got to do this same thing, add 2 pi, because I've got the 3 in front, so we add 2 pi, which is really adding 4 pi over 2. Boop. 7 pi over 2. Boop. 11 pi over 2. Yeah. Oh, no. Then the last thing I got to do is get rid of the 3, so I divide by 3. So it's like multiplying each denominator by 3. So I get, that thing would get you pi over 2, 7 pi over 6, and 11 pi over 6. Again, for those, the radius is -2. I'm sorry, radius is -6. So at pi over 2, we have a radius of -6. So what happens? Oh, if it was right here, it's a negative radius, so I ride across the other side. I had 7 pi over 6. I ride the line across the other side. 11 pi over 6. I ride the line across the other side. That's why we don't see twice as many petals when it's odd, because it goes back on top of itself. Okay, that's why we don't double it. Let's see how this works. Again, that's the deep understanding of why we do that. But now let's do the easy part of this, and we'll see what's going on. So look at these notes. I hate the directions on this first part. I did a terrible job of writing them out. So here are the directions I'm going to give you. Basically, just disregard. For each rows, we're going to figure out how many petals are there, what is the maximum, and when is that maximum going to happen. How many petals, where is the maximum, and when is that maximum going to happen? So let's start off by doing that. As I look at this first one, how many petals is this first row going to have? It is 4. Remember, if it's an even number in front of my theta, we do double that. So if it's a 2 right here, that's going to tell me 4 petals. Okay, and then we're going to do what we did the other day. We're going to find the maximum radius. What is the biggest number I could get here? And think about what that looks like. It's 5 times this guy. Sine of anything can only be between what 2 numbers? 1 and -1. So this number that would go right here is going to be either 1 or -1. What number do we want it to be here? 1. If it's a 1, what would my maximum radius be? The maximum radius would be 5. But we need to solve that question. We need to figure out there's a maximum radius of 5 at what angle? And to do that, it's about solving this equation. We said we want sine of 2 theta to be 1. And so when is sine going to get me 1? At pi, let's go degrees just because it's easier. 90 degrees. At 90 degrees, but that means that 2 theta is going to be 90 degrees. So when is theta actually going to be 5? At 45 degrees. Okay, we had to find where the maximum is happening, but then don't forget to divide by 2. Again, this isn't just random gibberish. If I were to graph that thing, r equals 5 sine 2 theta. We had a maximum right here at 45 degrees. It is a maximum of 5. That's what we just stated as we did it, and it has 4 petals. Everybody good with that first one? The next one. Okay, I changed it just so they weren't all the same. I made it 4 theta. Try to answer those questions again with your neighbor here. Try to figure out how many petals are there? What is the biggest R value you could possibly get? And where is that going to happen? Talk to each other. Show me with your fingers, how many petals is this guy going to have? There are 8 petals on this one because we've got a 4 right there. Remember, if it's an even number, we're going to double it because it's going to have both values. Show me with your fingers, what's your maximum radius you could get here? If it's a rose, it's easy. It's just the number in front. It's this 3 right here. Okay, but we're answering the question basically. I want this to be 1. That's what's going to get me a maximum of 3. So I want to know when cosine of 4 theta equals 1. So 4 theta would be equal to 0. That's when cosine is going to get me 1. So what is my angle going to be? 0. Does that make sense? All right. Don't overthink it. Let's try one more. Number 3. R equals negative 7 sine 5 theta. We do the same thing we just did. Amount of petals. Show me with your fingers. How many petals is this guy going to have? How many petals? It's 5 because it's an odd number. It's going to stay that same because it's going to go back on top of itself. Okay, so there's going to be 5 petals. I'm going to have a maximum R equal to 7. To make it 7, what do I want sine of 5 theta to be equal to? Negative 1. When is sine going to get me negative 1? At 270. So what I'm really asking is when is 5 theta going to be 270? Because if this is 270, that would make it negative 1. So what would I need to do to find the angle? Divide by 5. So in my calculator, you take 270, you divide it by 5, and you get 72, or no, I'm sorry, I lied, 54. I can't do math. 54 degrees. And we'll do that exact problem here in a second, but that's what we're trying to find. Questions so far? That's going to be way harder than the actual graph. The graphing part of this thing is easy, so stay with me here, okay? So number 4, we're trying to figure out what type of graph it is. If it's 2 cosine 2 theta, what's my shape going to be? It's a rose. It's a rose. I didn't add or subtract anything with cosine, so it's just a rose. Show me with your hands, what type of symmetry does this graph have? It has x-axis symmetry, so it's like an alligator. You can fold it straight down. X-axis symmetry. The maximum we're going to have here. What is the biggest number my radius can be? 2, because of that right there. But to figure out when that's going to happen, I want to know when cosine of 2 theta gets me 1. So when is cosine 2 theta going to get me 1? Well, cosine gets me 1 at 0. So at what angle is 2 theta going to get me 0? At 0. At 0 degrees. That's when I'm going to have a maximum of 2. So a radius of 2 at 0 degrees. That is one of my maximums. Okay, and we could do some different things to find the rest of them. I could work my way around. I could use symmetry. I'm going to do this the simplest way possible. Okay, it's a rose. It's a flower. It's pretty. It's symmetrical. Okay, that's the key here. It's very symmetrical when we graph this thing. How many degrees total are there in a circle? We have 360 degrees, and we are going to divide it into how many equal petals? 360, because it's a 2 right there, we double it, so we're dividing it into 4 petals. So if I take 360 degrees and divide it into 4 petals, how far apart is each petal going to be? 90 degrees apart. That's what we decided. We took the circle, 360 degrees, and we divided by however many petals we have. That will tell you that each rose petal needs to be 90 degrees apart. Okay, there are 4 petals, so I know I'm going to have 4 points. The first one's at 0. To find my next one, I just add 90 to it. So where's my next one going to be? At 90. So one's at 0, one's at 90. The next one's going to be at 180 because I'm just adding 90 to it again. My next one would be 270. And you could keep going, but you would get back to the start and they would start repeating over top of itself. It's always going to go through the point 0, 0, and it's going to make a rose. So let's make sure we know what this picture looks like. Go on your calculator. We're going in my calculator. We go to R equals. I'm going to type in what we just said. So it was 2 cosine 2 theta. We type that thing in. We hit graph. There is my graph. Okay, my window is a little bit weird. I'm going to slow this thing down. So I'm going to go 0 to 2 pi. I'm going to slow this thing down so you can really see it. Don't change yours to 0.005. My calculator is a computer, so it goes a little bit faster processing power. But watch that thing as it graphs. See how it works its way around. If we were to graph these points individually, that's exactly how it would graph it. Okay? Boom, just like that. So I'm going to try and draw that the best I can. I like to follow what my calculator does because I think it's helpful to me. But I'm starting right here, and I'm going to loop my way around. So I'm here. I'm going to loop, 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 back to the start. That's pretty. That was impressive. You're correct in saying so. It's a wonderful flower that I just drew. Okay? Do the best you can. Do think loopy. I think it's easiest if you do it all as one stroke, but if you want to make it as just 4 petals and just connect the dots, I'm good with that too. Questions on how I drew it? Look at my screen for a second. This is important here in a second. I'm going to change my theta max. Right now it's at 2 pi, 6.28. What do you think is going to happen to my picture if I just graph 1 pi? Let's look. And I'm done. It gave me half of it, right? Because I only went to 1 pi. It makes sense that I only got half my picture. Everybody cool with that? All right, I'm going to change that back for later. All right, let's go to the backside. We're going to come back. Number 5 is easier to graph, so I'm going to have you graph that on your own in a second. Let's go to the backside and graph one of the harder ones together here. So -5 sine 5 theta. Is that what's on the top on the backside? Cool, let's do it. Type of graph. It's a rose. Show me with your hands. How are you going to be able to fold this graph? Like a seal. Y-axis symmetry. Not a walrus. That's ridiculous. Who would say a walrus? That's crazy talk. Maximum. What is my maximum radius going to be here? It's 5. Okay. What would I want to put in for sine of 5 theta to make this a maximum of 5? -1. So what you're really going to answer, to fill this in, we want to know when sine of 5 theta is going to be equal to -1. That's what I'm trying to figure out here. When is sine of 5 theta equal to -1? So to do that, I'm going to do inverse sine on both sides. I'm going to figure out, oh yeah, 5 theta, when is sine? Oh, that's going to be at 270 degrees. And then I'm going to divide by 5. 270 divided by 5 is going to get me 54. All right, cool. 54. That is one of my petals. At 5, I'm going to 54 degrees. Ooh, I'm going to have to do the best I can. Here's 5. 54 is going to be somewhere right in there. I'm going to put a dot. How many petals altogether am I going to have? 5. And so I'm going to have 5 ordered pairs. Okay, I know I'm going to have 5 ordered pairs. My first one's at 54. To figure out where my next one is going to be, the best way to do that is to think of a circle. It's 360 degrees all the way around my circle. If I took that 360 and divided by how many petals I have, I would divide it by 5. 360 divided by 5 petals is going to tell me that I have a rose every 72 degrees. Okay, or 72 degrees apart is going to be how far apart each rose petal is. We took 360 degrees and divided it by 5. So my first one's at 54 degrees. What would I need to do to find my next rose petal? Add 72. So in my calculator, I'm taking 54 plus 72. I get 126. So my next petal is going to be like right in there. And then I just add 72 again. My next petal is going to be at 198. So that would be 195. So just a little bit below that. And then I add 72 again. I get 270 degrees. So right here. And then I add 72 again. I get 342. So 342 would be right about there. There are my 5 dots. And I'm going to also include a dot right there in the center. Everybody good to this point? To connect the dots, you can just connect them, but I always like looking at a picture. I'm going to hit y equals. I'm going to type this thing in. So we're graphing -5 sine 5 theta. Is that correct? -5 sine 5 theta. Type it in. I'm hitting graph. It's pretty slow here, so we should watch it. Oh, it's going a little faster this time. Boom, boom, boom. Around. Back to the start. There's my rose. Does it have y-axis symmetry like we thought it was going to? Yeah, it should match up with my dots. That's about where my dots were. Use your calculator as your friend. As you graph these on a test or quiz, yeah, you should have the picture out before you do anything else. Because if you're looking at the picture, you're going to make less mistakes. Oh, no. I was so good. Oh, no, don't do that. It's bad. It's bad. Oh, no, I got lost. I got so lost. I was doing okay. Oh, I'm doing this so incorrectly, but that's all right. I'm just going to live with it now. And I picked up my pencil. In the end, it's not terrible, but it was really bad. Don't follow how I just did that. I got a little off in there. Yes, sir. Oh, my 126 dot is off. That's what's throwing me off. I graphed 126 incorrectly. It should be right there. I was off just a touch. I put it on the other side of 126. That did not help my struggles. That last one gets a little wide. There's my graph. They're not all pretty, but there's my setup. Watch this. This is important, okay? Watch this. I'm going to change my window. We did this a second ago. I graphed from 0 to 2 pi again. What do you think is going to happen if I change it from 0 to pi? What do you think is going to happen with my picture if I graph it from 0 to pi? Watch. Ready? Do you see the difference? You can't see the difference. It's the exact same picture. Okay? Watch it again. I'm going to go back to 0 to 2 pi. So 0 to 2 pi. If you look in the top corner, I'm going to slow this down even more. 0.00. Don't do this because this might break my computer. This will be fun. We'll see if it breaks. Let's delete that out. I slowed it way down. All right, it's not bad. All right, look, see up here in the corner? See where it has this little yellow thing that's telling you it's graphing? So right now it's going around. We're touching all these dots. I went from 0 to 2 pi. Okay, we get all these graphs here. Watch, we get back to the start. And look at that yellow circle in the corner. See how it's still running? See how you can't see anything different? It's because the graph is repeating on top of itself. Think back what we did in Bellwork. Okay, when we got those negative radii, it started repeating and you couldn't see the difference. It's because it's just going back on top of itself. Right now it's redrawing the whole thing again. When it's an odd number, we only have to graph it through 0 to pi because it's going to just start repeating the process. When it's even, we got to go 0 to 2 pi because otherwise I wouldn't have the full circle. Kind of makes sense? That's weird. Don't let that be too much to you. All right, flip your paper back over to the front side. Try and graph that front side one with your neighbor. See what you can do without me helping you. Go. We go to graph this thing. It's a rose. 3 petals. What's the symmetry going to be? X-axis symmetry. The maximum is going to be 4. And to figure out 4, we want to know when this gets me 1. Because if that's going to get me 1, it's going to get me 4. So I'm trying to figure out when cosine of 3 theta gets me 1. Well, cosine gets me 1 at 0 degrees. So if I divide by 3, it's at 0 degrees. Most of the time, it's not too tricky. The one on the back side is the trickier one. That's when we got to pay attention. But 0 degrees. So 4, 0 degrees. That is one of my petals. How many petals am I going to have altogether? 3. We take 360 degrees. We just split it into however many petals. So we split it into 3 parts. 360 divided by 3 tells me I have a rose petal every 120 degrees. They're 120 degrees apart from each other. So one of them is at 0. My next one's going to be at 120. Then I add it again. It's going to be 240. And if I add it again, it'd be 360. So 0, 120, 240, 360. I didn't go wide enough. And then we connect those dots. You could graph this in your calculator, but it's going to look something. Oh, I missed. Oh, we're close. All right. I'm terrible. Good enough on that one. Roses are not too bad. We could get into the thinking and understanding and explaining why it has less petals, but we're going through it. If I were to only graph from 0 to pi, would I see half of that thing or would I see the whole thing? The whole, because it's an odd value. It's going to start repeating on top of itself. Okay, one more. Go to the backside. My last one here, we're going to graph this one in radians just because of what they gave it to me as here, 1 over theta, or 1 over pi theta. What type of graph is it? And maybe the best way to do it is to start off here. What is the maximum radius? What theta could I plug in to make this as big as possible? It's infinity. Why is it infinity? Because this thing doesn't have a limit. My other graphs have been limited by sine and cosine, because sine and cosine are going to stick between -1 and 1. But this one doesn't have sine and cosine, so it's unlimited. Okay, so we're not really going to have an answer for where it's at because it's not going to stop. It's going to keep growing and growing and growing. So what type of graph is it if my radius never has a limit here? It's a spiral. What type of symmetry is a spiral going to have? Is it a sine graph or cosine graph? Neither. So it doesn't have any, don't make that an X. It doesn't have any symmetry. Okay? There is no symmetry here. It's not x-axis symmetry. There's not any symmetry here because it's a spiral. Think about what a spiral is. It looks pretty cool. It looks somewhat symmetrical, but it's not. Now, I do need to give an interval because if I don't give an interval here, you're going to graph forever. You would never stop graphing on your paper. If I just told you to graph this, you would have to work until the end of time. So I should probably give you a limit. Let's go from 0 to 4 pi. Okay, 0 to 4 pi. We are plugging in to this simple formula. 1 over pi theta. So let's do that. Let's start off at 0 degrees or 0 radians. If I plug in 0 right here for theta, what is 1 over pi times 0 going to get me? 0. So if I go to 0, 0, that's going to be a dot. What would be another angle that we should plug in here? How about pi over 2? Everybody okay with that? Pi over 2. If we plug in pi over 2, then it's going to be 1 over pi times pi over 2. what is my radius going to be if I take 1 over pi times pi over 2? It's 1/2. Okay, so we're going to get pi at pi over 2. So up here, I'm up at 1/2. Then let's just keep working our way around. So now let's try pi. So if I plug in pi, it'd be 1 over pi times pi. What would the radius be at pi? It'd be 1. So right here, I'm going to have a dot at 1. So at pi, which is over here, it's at 1. Let's keep going. So let's do 3 pi over 2. So for that one, it'd be 1 over pi times 3 pi over 2. What's my radius going to be? 3/2. So it's 1.5. So down here at 3 pi over 2, I'm at 1.5. Keep going. Now let's go 2 pi. If I plug in 2 pi, it's 1 over pi times 2 pi. The pi's would cancel. 1 times 2 is 2. So over here, back at 2 pi, now I'm at 2. And you could keep going. Hopefully you're seeing a pattern. This is 2. Then at 5 pi over 2, I'd be there at 5/2. Over here would be 3 pi. So if I plugged in 3 pi, I'd be there. If I plugged in down here, it'd be 7 pi over 2. So I'd be at 3/2 or 3.5. And then if I came back here, it would be 4 pi. If I plugged in 4 pi, I would get 4. You can go in your calculator, but you can kind of follow that pattern that we just did. I'm going to start right here, and I'm going to swirl my way out. And I stopped. I stopped again because I was on the interval from 0 to 4 pi. If I were to type this in my calculator, 0, 4 pi, y equals, let's type in what we just did, alpha f1, 1 over pi, and then times theta. Times theta, hit graph, boom, there's my spiral. Again, if I change that window, instead of stopping at 2 pi, I went to like 9 pi, it would just keep working its way out and further and further and further. You could keep adjusting that as big as you wanted, and you could keep seeing it spiral. Eventually, your calculator breaks because it doesn't like graphing that much. Questions on something we did today?